Hello friends, welcome in Cadence tutorial. I am Madan Kumar Jha and today I am going to explain how to design a schematic of a pass transistor logic using NMOS and PMOS. So first of all go to file, then in new, then in cell view. Actually I have created a library that is Cadence tutorial. So this all have I explained in earlier videos. So you can go to my first videos and you can see how to open cadence and jamming and then how to make any library. So here now I am going to make pass transistor logic using NMOS. So I am giving its name NMOS PTL. Okay, then go to session. So this is the cadence workspace. So here I have to make a schematic of pass transistor logic using NMOS. So for instance press I, then here in GPDK 180 you'll find NMOS. So this is NMOS. Now I'm going to rotate it accordingly. So I have drag NMOS to here. Now this is the NMOS. So I want to see its characteristics as a pass transistor logic. So as we all know that NMOS can pass 0 strongly and 1, that is VDD, weakly. So I have to see that is it correct or not. So first of all I have to give the gate voltage to turn on this NMOS. So for that go to source, so instance, then in GPDK, then in analog library I will find that voltage source VDC. So I am giving the DC voltage of 1.8 volt, 1.8 volt to this PTL. Okay, now I'm going to rotate it, then hide. Okay, now again in analog library I will find ground. So this is the ground terminal. Now I want to rotate it. So press R for rotate. Okay, then escape. So the gate voltage is 1.8 volt, which is sufficient to turn on this NMOS. Now I have to supply a certain amount of voltage to source to see that is it actually passing to drain or not. Okay, so basically NMOS pass transistor logic is passing the minimum of this VGS minus VTH or VDS. Okay, so sorry, or VS, either it will pass this voltage or minimum of this minus VTH. Okay, so again go to source and then in analog library I will get B pulse. So go to V pulse, then set voltage 1 to 1.8 volt and voltage 2 to 1.20 volt. Okay, and then define its period. So I'm going to give a period of 10 nanosecond. Okay, then delay is not required. So now I have to give pulse width. So I'm giving the pulse width of 5 nanosecond. which will be creating a square wave. Then I'm going to hide it. Okay, now again I have to bring a ground, so go to analog library again and then here search for ground, or just copy from there also. So here this is the ground, so the negative terminal of this people should be connected with ground, so I am going to connect it. Then using W, that is wire, I have to connect this with the source of NMOS. Okay, then bring this down and connect the body of NMOS with the ground terminal. This will actually, body of NMOS is connected with ground and body of PMOS is generally connected with DC voltage, because it will reduce latch-up phenomena, because a diode is found between the devices, which will create direct current. So this latch-up phenomena will be reduced, and also the body effect will not occur if you connect this. If body effect will occur, then the VTH can be changed. So for that purpose, I have to connect the body of the NMOS with ground and the body of a PMOS with VDD. Okay. Now create a pin, that is input pin. So I am giving its name as I. Okay, or A. Okay. Then hide it and connect it with this wire, so that I can see our input in the waveform. Then again create a output pin. So press P, change the direction to output. Then I'm giving its name Y. Then hide it. Okay, so this is the output pin. You can rotate it using R for a good looking schematic. Now W for wire and connect this drain of NMOS with this pin. Okay, so now our schematic is fine. So I'm going to check and save. If there will be any error, it will show in home sections, but our schematic completed with no errors. Okay, you can see here. Now go to launch, and in ADEL launch, always press to session when this will occur. Okay, now go to transient. I want to see its transient analysis, so go to edit, then set a time of 400 nanosecond. It will be the simulation times. Okay, then accuracy default should be moderate. Then okay, now in output section, right click here. I want to see its output also. So from design, you have to go to design and select which output you want to see. So I have to see input as well as output, that means A and as well as Y, because then I can compare that is there any drop of VTH in the output section or not. Okay, so I'm going to select this A as well as this B, Y. Okay, now go to section of setting output, then press OK. Then in ADL, go to setup and check for model libraries. Is there only GPTK 180 available or any other? So here only GPTK 180 nanometer is present, so no need to do anything. If you find others, so uncheck that all 9045, only you have to select this GPTK 180. Okay, then run this simulation. Okay, so actually I have used here 1 comma 8 instead of 1.8. Due to that this error is shown. So again I'm going to properties of this bpulse. So go to properties and then change this 1 comma 8 to 1.8. Okay, then press OK. Now everything is correct. Then go to again check and save, and after that again go to launch and launch it. So you can see here this is the output of a pass transistor logic. So basically when I'm going to make it more thicker, and I want to change its color to yellow. Okay, so this is our output, this is input. So input is in the form of V pulse. Okay, so you can see when output is 1.8 volt, when input is 1.8 volt, output is 1.24 volt. It means there are some drop of VTH in output, and it comes because this drop is basically VDC, that is VGS minus VTH drop. Okay, so the drop of VTH will be occur here because our pass transistor logic always pass either this voltage or the minimum of VGS minus VTH. Okay, so it is working fine.